Hello guys, we'll be doing this interesting question. I mean, it's an easy but integral, so integrals are always interesting. So we'll be doing this interesting question from 9709. It's from the same paper actually, paper 3-2, February March 2016. It's question number 5. So let's just get right into it. First of
Solve all your doubts on A-Level Insight Plus.
all, what we have here is an integral I, which is a definite integral which goes from 0 to 1 of 9 over 3 plus x square whole square dx. Correct? No. What have been asked? Using the substitution, x is equal to root 3 tan theta, so that I is equal to root 3 1 by 6 pi, root 3 from 0 to 1 by 6 pi of cos square theta d. We have to turn this integral into this form by substituting x as this. So first of all, let's write this x is equal to root 3 tan theta, right? Now, if we are substituting x as something with theta, we have to substitute dx with d theta, right? So to find what is d theta in terms of dx, we can say we can differentiate both sides here. We get dx is equal to differentiation of root 3 into tan theta. Say root 3 is a constant, so we can just exclude it. Differentiation of tan theta is actually sec square theta. Differentiation of theta is actually d theta. So using chain rule, we have d of x is equal to root 3 x square theta d theta. Now, we also have to find limits, because these two limits are for the values of x, not for the values of theta, right? So when x equals to 0, 0 is equal to root 3 tan theta, so theta is gonna be 0. Then again, when x equals to 1, 1 is equal to root 3 tan theta, so theta is equal to tan inverse of 1 over root 3. It's gonna be 30 degrees or pi over 6. So till now we got this, we also got this. Now for cos square theta, right? So our next step would be to substitute x as root 3 tan theta and dx as root 3 sec square theta d theta. So integral, if we are substituting now theta, we have to substitute the limits. So it's gonna be from 0 to 1 by 6 pi of 9 into root 3 into sec square theta into d theta whole over 3 plus root 3 tan theta whole square. First and foremost, let's just solve the denominator. I'm doing this separately. You can do this in the same space because we have to conserve the space in the paper. So we have 3 plus root 3 tan theta whole square, right? So we can do something like 3 plus 3 tan square theta whole square, right? Then if we take 3 common, we have 1 plus tan square theta whole square. And we know, according to trigonometry identity, that 1 plus tan square of theta is equal to sec square of theta. So now what we have here is 3 square is 9, and we have here sec square theta whole square. And then the final value is 9 sec 4 theta. So if we substitute that, we have 1 over 6 pi, an integral from 0 to 1 over 6 pi. So it's 9 into root 3 into sec square theta all over 9 into sec to the power 4 theta d theta. So this is cut, and here it's gonna be 2 This is cut. So now we have root 3. We can take it outside because it's just a constant. Integral from 0 to 1 over 6 pi of 1 over sec square theta. Sec square and divided by sec to the power 4 is 1 over sec square theta d theta. And we know that 1 over sec theta is equal to cos theta. So we can substitute this. So we get I is equal to root 3 integral of 0 to 1 over 6 pi of cos square theta d theta. So we prove this, right? So we showed this, we got this. So number I is done. Now we have to find the exact value of I. So that means we have to complete this definite integration, right? Let's just write it here in an empty space so that we have much more room. So I is equal to integral from 0 to 1 over 6 pi cos square theta d theta. So do we have any definite formulas to integrate cos square theta with respect to theta? No, right? We only know that integral of cos theta is equal to sin theta, and integral of minus sin theta is equal to cos theta. We don't have anything about squares of trigonometric functions, right? So we have to find something that is easy to integrate. Okay, for now we have to find something that is easier to integrate than cos square theta. We have to find something that can replace this trigonometric function, which might be another trigonometric function, or substituting it so that there is no powers, right, for trigonometric functions. So cos square theta can be written as 1 minus sin square theta, but then we get sin square theta again, and that's not easy to integrate either. So one thing we know is cos 2 theta is equal to cos square theta minus sin square theta. This is what we know. We have cos square theta, we have sin square theta, and we also have a term of cos with no powers, cos 2 theta. So if we substitute sin square theta for 1 minus cos square theta, get cos 2 theta is equal to cos square theta minus 1 plus cos square theta, and then we have 2 cos square theta is equal to cos 2 of theta plus 1, and then we have the value of cos square theta, which is 1 by 2 cos 2 theta plus 1 over 2, and this exact value will be substituting here so that we can easily integrate this. This will be sine 2 theta and by 2, and then this is gonna be theta. So I'll tell you about that in a while. So we have 0 to 1 by 6 pi of 1 by 2 root 3 outside cos 2 theta plus 1 by 2 d theta, right? So d theta, right? So we can solve this as root 3 from 0, sorry. The integration of 1 by 2 cos 2 theta is 1 by 2 is common, right? So no, actually we can do something like this. Root 3 and then integral from 0 to 1 by 6 pi 1 by 2 cos 2 theta plus integral of 0 to 1 by 6 pi of 1 by 2, and then d theta, and then d theta. So now integration of 1 by 2 cos 2 theta is gonna be, first we integrate the outside value, which is gonna be sine 2 theta, but we also have 2 in front of theta, right? So for that we have again divided by 1 by 2, and we already have one more 1 by 2 here, so it's gonna be sine 2 theta over 4. Got it? So why did I say this was? If we differentiate sine 2 theta over 4, we have we get first cos 2 theta, and then we get 2 using chain rule. 4, 2 and 4 gets cut, so it's going to be 1 by 2 cos 2 theta gets here. So we have to take care of the coefficient of the variable as well. So integral of 1 by 2 cos 2 theta with respect to theta is sine 2 theta over 4. So we have here integral of 1 by 2 is just 1 by 2 theta, right? It's just a constant. So I is equal to root 3. We have sine 2 theta by 4 plus 1 by 2 theta from 0 to 1 by 6 pi. So following this, we have I is equal to root 3 into sine 2 into 1 over 6 pi over 4 plus 1 by 2 into 1 over 6 pi minus sine 2 into 0 by 4 plus 1 by 2 into 0. That this whole term is gonna be 0. So I is equal to root 3 times it's sine 2 into 1 by 6 sine pi by 3. That's gonna be root 3 by 2. So it's gonna be root 3 by 8 plus 1 over 12 pi. So our exact value of I is 3 by 8 plus root 3 pi by 12, because exact value means third form.